my name is Josh Noble, and I'm a student in the Masters of Public Health program at Liberty University. And I'd like to just share with you some of the results and things that I learned in my practicum experience, which is at the end of my program before I graduate with my Masters of Public Health. So I did my practicum experience with an organization called Unto. Unto is a ministry of Cru, which is often known for its campus ministry, but Unto works as a public health organization within Cru in order to better serve people around the world and spread the love of Christ to all people. So my specific contribution was in developing a system that could use zero valent iron to remove heavy metals from surface water. And specifically, I worked on copper. And this was a part of the research and development kind of initiative that Unto is trying to really focus on recently. And I worked as part of the WASH, the water, sanitation, and hygiene part of Unto. And so heavy metal contamination is a huge problem around the world. It's one that Unto has had its eyes on, especially those working within the WASH department of Unto. And they want to be able to provide some kind of program, some kind of project option for different people, different communities around the world that are suffering from heavy metal contamination. And now, heavy metal contamination in water does contribute to a host of health problems, all kinds of respiratory problems, liver problems, even cancer, developmental problems in kids, and all kinds of really bad conditions. And so this is a really big priority, something that even public health practitioners are noticing more and more is a growing problem around the world. And so there needs to be more practical, cost-effective solutions for combating and removing these heavy metals from water. And so the aim of my practicum project was to develop, to build, and test a practical, cost-effective way of taking out heavy metals from water. Specifically, we focused on copper in this project. So the first phase of this project focused on research and design of this system, and then resourcing. So zero valent iron, as I mentioned, zero valent iron was identified as a possibility, a potential substance that could be used to take out these heavy metals through different redox reactions and through different metal interactions with the different heavy metals that could be in water. And so it was also identified that sand, when combined with sand, ZVI is effective and more sustainable in the long term than just putting it through the zero valent iron by itself. So a prototype was designed and planned to be built based on those two things, and seeing the existing research that showed that zero valent iron it was a possibility for taking out these other heavy metals. As far as resourcing goes, Unto provided the financial backing and the encouragement for me to pursue this project, so I'm really thankful to them for that. And the hope for this project is not just to stop here at this prototype, but that this project will be used in the future for helping communities all around the world in combating heavy metals and taking it out so they can have clean water and not be worrying or getting these bad adverse health conditions that are caused by heavy metal contamination in water. And so, based on that, this prototype needed to be made with materials that could be found all around the world and sourced somewhat locally in many different countries. That way, it's not something that's highly specialized that can only be found in the US or other high-income countries. So the design of the prototype focused first, an inlet pipe went through a pre-mesh filter, which would filter out any dirt or anything like that that's in the water. And then it would be distributed around, the prototype was made of a 5-gallon bucket, so it was distributed around the whole 5-gallon bucket, and that the topmost layer was a layer of sand, and this sand would also better help to distribute the water all around the bucket. Then in the middle, you have the ZVI and sand mixture. A 1 to 3 ratio was used, which showed a high effectiveness. Um, a one part ZVI to 3 parts sand. So 10 pounds of ZVI were used and 30 pounds of sand were used and mixed all together and then poured into that. And then a layer of geotextile fabric was then put under that layer, and then a at the very bottom was a limestone layer that would keep a pH of 8.2, and that was really important for the long term sustainability of this ZVI system. By keeping it at 8.2, it would slow down the oxidation of the zero valent iron particles, which would help for a longer effectiveness for this. And so this whole prototype, this whole project was made with the field in mind, that this is going to be used in the future in communities, hopefully all around the world, dealing with heavy metal contamination. Um, so some of the setbacks that I experienced, some of the things that I wasn't thinking I was going to have to deal with, but I did in building this, was just the modification of the bucket lid, and the bucket itself was very difficult to actually do. The drilling a 1 inch hole in the plastic lid proved very difficult. It was very difficult to get it uniform, and I was not able to get it uniform. Um, Furthermore, the bottom of the bucket, to actually drill a hole in that, was very difficult. I did it on one bucket and it cracked all the way through, and so I was very careful with the second bucket I had, and I wasn't able to drill a hole as wide as I wanted to. It was only about 1/4 of an inch, and so that was difficult. And then to on top of all that, the the low energy of the bucket. So it was a food grade resin bucket, and the low surface energy doesn't allow for bonding of various sealants. So I tried silicone, I tried caulking, I tried other sealants, but it wouldn't work to actually bond to it. So I had to throw out some of my design plan for putting PVC piping on the bottom of the bucket, and that just wouldn't work. And then as on top of all that, there was weather that wasn't good for testing or making it. And then there was some scheduling issues, some different resourcing things that were difficult. So that was some of the setbacks. But then as far as the successes, there was also the mixing and actually pouring of the different layers of the sand, of mixing the limestone. Mixing the ZBI and sand together and then pouring the limestone. All of that went very well, much quicker than I thought it would be. So that was very good. And the filter was completed by the end of October, which was a little bit behind schedule, but also early enough in the year. I live in Arkansas, so early enough that I was able to test it in time. Um, and so finally, actually testing the ZVI filter, I identified copper as the heavy metal to test it, and copper solutions with concentrations of 5 milligrams per liter, 10, 15, 20, and 30 were mixed and then all tested. And across all of the solutions, there was a 99% or more reduction in the amount of copper that was in, shown through using test strips. Um, and so this corresponds to many other studies that show that ZVI is very effective for moving heavy metal from water. And this shows it with copper particularly. This is very, very exciting because this could be very, very helpful for many communities around the world, many people who are experiencing all the adverse health conditions that come with drinking contaminated water that's contaminated with heavy metals. And so these are exciting results to have a practical, low-cost solution like this. Even though there were some issues with making it, it's still very exciting to be able to have these results and to be able to offer this to people around the world, hopefully. Um, so some recommendations for future research. As I mentioned, some of the materials I used did not work very well, or I didn't have the proper tools perhaps to really make them work well. And so more studies on being able to use different materials and better materials for this kind of setup would be very, very helpful. Other studies could look at the long term effectiveness and sustainability of a system like this. I made it over a few weeks. I tested it after a few weeks, and so there wasn't a lot of environmental exposure. There wasn't there hasn't been really very cold nights, and so that I don't know if that would affect the efficacy of the ZVI in the filter. Um, and so another thing, just look that would be just looking at the sustainability of it. Also testing different heavy metals in the filter and seeing how it responds to those, and then also seeing how it might respond to multiple heavy metals at the same time. That's some thing for other research. I'm really excited of these results. About these results, this project was very fun. It was difficult, but I had a great time doing it. I learned a lot, and I'm very thankful to Unto and to the Wash team for all the support, all the encouragement that they gave me, and just being able to do this, and to Liberty University for pushing me in the Masters of Public Health program to really excel and to really contribute to community health. Thank you.